Okay, this is my screencast assignment for Physics 101, Professor Morrison's class. In an effort to get away from the security guards chasing him, a bank robber runs up the stairs of a bank to the roof of the building. The bank is a 5-story building, and the next building over is a 4-story building. Assuming the bank robber is capable of jumping with a jump velocity of 10.5 meters per second at a 10-degree angle relative to the flat rooftop, how far away can the neighboring building be and still allow the robber to land on top of the other building? At the maximum safe distance, what will the robber's velocity be when he hits the other rooftop? What we can tell that we know and what we don't know are from the variables given in the problem. We know that the initial velocity is 10.5 meters per second. We know that the acceleration at x is 0 and the acceleration at y is a negative 9.8 meters per second. What we don't know is the distance, the maximum distance, and the velocity final. What we're trying to solve for will be these two. For the distance, I'll be using the formula y equals y plus velocity iy times c plus half acceleration of y times time. The VIY can be found by using VI times sine, and the theta. In this case, that would be 10.5 times sine 10 degrees, which would equal out to 1.82. By plugging in what I have, I still need to solve for time. Whereas I have the acceleration as a 9.8 on the y-axis, time is still unknown. To find time, I use the formula time equals a divided by v, acceleration divided by velocity. The acceleration is given to us as negative 9.8, and that would be meters over seconds, and the velocity is 10.5 meters over seconds. Seconds would cross out, as well as the meters, leaving us with the time to be negative 0.933 seconds. By plugging that back into the formula, we get 0 plus 1.82 times negative 0.933 plus a half of the acceleration times the negative 0.933 squared. Through this formula, I was able to find that y, or the maximum distance, is equal to negative 5.96. To determine the final velocity, use the formula velocity final equals velocity initial for y plus acceleration times time. Acceleration on the y-axis times time. Plugging in the variables that we have, that would be 10.3 plus negative 9.8 times negative 9.33. By doing this, we find that final velocity is equal to 10.96.